Welcome back, Akira Bike Project fans. We left off the last video with this beautiful result of the CX500 rebuild and painting. Since that's all done now, it's time to get it set up and running. I decided I would build this engine test stand to test and tune this engine, as it makes accessing it extremely easy, and will be beneficial if I need to start making more of these. The engine test stand will feature all the wiring, electrical, fuel, and cooling necessary to test and tune the engine. I started out with the left side of the test stand. This piece, along with the rest, would be removable so the engine could be easily removed. It consisted of two parallel square tubes on the base, connected with two pieces of angle iron, and two tall angle irons on the back connected with another square tube. I cut the square tubes and angle iron and started with welding the base. I then added the tall back angle irons and welded those in place. A few short pieces of angle iron welded around the base square tubes would make for a nice receptacle for the center piece of the engine stand I had already made, and lock it into place to prevent rotating. With that, the left side of the engine test stand frame was looking pretty good. I moved on then to the right side of the test stand, which would hold the radiator and controls. This was constructed the same way with a square tube base and angle iron back and receptacle sleeves that slide onto the existing base. Afterwards though, the two pieces are connected together with another part in the middle along the top. I bolted the middle piece to the left and right side, and then bolted plywood panels above each section, and these panels were where the wire housing and various other accessories would get mounted to. The right side base got a plywood mounting plate as well, which needed some corners notched out to fit properly, and the left side base got its own mounting board. I rebuilt the engine, but so far the carburetor had remained untouched and was still a 40-year-old corroded and clogged piece of junk. So it was time to disassemble and rebuild the car. Over time, the lighter hydrocarbons in gasoline evaporate and the remaining heavy hydrocarbons absorb water from the air, resulting in a sticky varnish-like substance. Modern fuel injectors have enough pressure to punch through this, but carburetors rely on the small pressure differentials of the Venturi effect from the rapidly flowing air to atomize the fuel. So when clogged up, these jets need to be completely removed and soaked in solvent to clear out. The CX500 has a dual Cv carburetor and has a separate carb for each cylinder bolted together with mounting brackets. I started out by removing these brackets and the intake manifolds and then removing the push-pull cables. I removed the jet needle and needle set screw from the vacuum piston. This assembly slides up and down depending on the pressure in the carburetor and contributes to fuel flow when the engine is above 50% throttle or so. I carefully separated the right and left sides of the carb, making sure not to stretch any springs too far or bend any components, and then removed the float bowls. These bowls on the underside of the carburetor house the fuel and contain small floats that plug up the fuel when they are full and are where all the jets get their fuel from. These were completely disassembled for a thorough cleaning as well. I tested the floats and removed the main jet, secondary jet, and pilot screw and soaked all these parts in carb cleaner and blew them out with compressed air. Moving back to the main assemblies, these are also sprayed and thoroughly cleaned with a metal wire brush and carb cleaner and compressed air. After soaking, the jets and needles are also cleaned and brushed, making sure to clean the internal passageways. The exterior of all the parts were also degreased, wire brushed, and sanded. With that, the carburetor was looking pretty good, so I went ahead and reassembled it and then reattached it to the engine on the test stand. I next built out an extension to the right side of the engine test stand. This would hold the handlebars, an ignition switch, various controls, and the radiator. I set up this fuel line and petcock valve and small hanging fuel tank in the background there to gravity feed fuel into the carburetors. I next fabricated this quick ignition switch mount and clamped it, as well as the existing handlebar and dash controls I'd already made directly to the engine test stand. One of the things my shop was missing, though, was a sink, and I'd been wanting to add one for a while. Thanks to an unusually large water bill, we discovered a leak under the house in our crawl space, which happened to be exactly where I would need to cut the hot water pipe to run a line into the garage where I wanted to put the sink anyway. So I decided it was time to get started on this. After some planning and a quick trip to the local hardware store to get the supplies, I got started. I cut out the corroded area of the pipe and installed a SharkBite Quick Connect T for the hot and cold lines, and passed the lines through into the garage where the sink would go. I plumbed the drain line next, connecting it to an existing ABS drain after cutting a small section out. And I put in some shut-off valves and connected everything up, and after that had a nice, deep shop sink. Back to the engine test stand, I next pulled out the wiring harness and gave it a good thorough cleaning and repaired any of the frayed connections and started connecting it to the test stand, mounting each component one at a time. I'll leave this wiring harness on this test stand and pick another up for my build, along with another stock instrument and controls so I can put my custom one back onto my prototype. This also helps me get familiar with the wiring for the CXs and getting ready to modify the harness and controls for the extended distances required on my build. After the wiring harness, battery, and controls were hooked up, I gave it a quick test to make sure it turned over okay. After that, it was time to connect to the cooling system. The CX was the first liquid-cooled motorcycle engine and recirculates cooling fluid through a radiator with a fan attached. I fabricated some mounting brackets to connect the radiator to the engine test head frame by first cutting some cardboard pieces to the right length and shape, and then cutting some 1/2 inch by 1/8 inch flat bar stock to the right length, and then bending it to the correct shape using the cardboard as a guide. The bar stock then had holes drilled on either end to use for mounting bolts. A similar bracket was made on the back side for the third mounting point of the radiator. I next fabricated a mounting bracket for the coolant overflow tank, which was a bit more complicated due to the odd shape of the tank. I'll be fabricating a custom tank for my build. Next up then were the radiator hoses, which were surprisingly expensive as far as hoses go. I guess to handle the high temperatures and pressures while also being flexible, they require a rather unique construction. The hot coolant here will flow in one hose into the radiator, is cooled down, and flows back out the other hose into the engine to repeat the cycle. So with that, I can add the coolant to the engine. After I added the coolant, though, I immediately noticed a small leak in one of the coolant pipes. You can see it here above the white cloth where the silver pipe enters the engine. Finding and easily troubleshooting issues like this, though, is the whole reason I built this test stand. But I wasn't as clever as I thought I was, since actually accessing the backside of the engine requires draining and disconnecting everything and rotating the engine around on the Lazy Susan. Well, it turned out just to be an improperly seated rubber O-ring and was an easy fix. But I would later end up just cutting a hole in the backside of the test stand, since a tool that could be easily moved was behind it, and now the test stand is as glorious as I had originally hoped. With the obvious leaks sorted out, it was time to try to fire it up. I put on the pod filters and adjusted the jets and choke, and it didn't start. I was shocked to see oil pouring out of the front of the engine, though, horrified, thinking I did something terribly wrong. But it turned out I just forgot to put the oil temperature sensor back in this hole here. With some additional adjustments and some fiddling and a little help from some starter fluid, I did finally get it to fire up. But only briefly at first. After some more testing, adjustments, and fine-tuning, it was running pretty well and sounding pretty good. And with that, I was confident the engine would at least be a viable power source for this build. It'll still need some tuning and testing, but getting it fired up and running after the rebuild was tremendously satisfying. That's all for this video. I'll leave you with the engine purring, and thank you for my patrons. If you like this project, please consider becoming a patron. Every little bit that you contribute helps tremendously in this project. And thank you all. See you again soon.